Tanaka and Nakamura from Merpay's data platform team will give a presentation of streaming processing infrastructure with Kafka and Flink SQL on Kubernetes. I'm Katsunori Tanaka, and I work as a software engineer on the Merpay data platform team. I mainly develop and operate data platform used in Merpay and Mercado services, along with Nakamura, who will be presenting after me. The main technologies I use include Scala, Python, Kafka, and Flink. So I will now begin the session. This session will consist of two main parts. In the first half, I will give presentation on the CDC infrastructure used by Merpay from the big picture to the detail. Then Nakamura from the same team will talk about the stream data processing infrastructure that processes data in near real time using data collected by the CDC infrastructure. So, first half of the session is about the CDC infrastructure of Merpay. Let me explain CDC. CDC stands for Change Data Capture, which is a mechanism to capture data changes such as create, update, and delete in the database in real time and store them in a data lake or data warehouse. This has the advantage of utilizing data faster than batch processing. Specific methods include log-based, trigger-based, audit, columns, etc. The available methods vary depending on the target database. Where is CDC needed in Mercari and Merpay? For example, this is used for analysis that require near real-time fresh data, such as anti-money laundering measures. This use case will be discussed in detail later. The CDC can also be used when a history of data is needed. For example, the database only contains the latest information on the user's status, but we want to track what transitions the user has gone through up to that point. Not to change the topic, let me show you an overview diagram of the CDC infrastructure that is developed and operated by the data platform team. On the far left are the microservices and their database that make up the actual services. From there, their data is retrieved by a cluster of Kafka Connect built within a Kubernetes cluster and Debezium, the OSS of CDC. We also use Flink and Kafka Connect to get data from Kafka, process it, and send it to BigQuery, and GCS for analysis to Cloud, Pub, Sub, and other database for use in services and to third-party services. To summarize, it is an orthodox configuration with Kafka as the hub. The sound is not available. The Kafka Connect is a framework for handling data input and output between Kafka and external systems, allowing you to retrieve data from various data sources in the form of connector and send them to Kafka, and vice versa. Merpay mainly uses JDBC connector to get data from Spanner and BigQuery connector to output data to BigQuery. Debezium is an OSS for log-based CDC and works as a connector for Kafka Connect. Merpay uses it to retrieve data from MySQL and PostgreSQL. Please refer to our recent article on Debezium and Kafka Connect on our engineering blog. Next, about Kafka cluster. Merpay uses a Kafka cluster built in Confluent Cloud. Confluent Cloud is a Kafka-managed service that allows you to build and use a Kafka cluster in a few clicks. Because it is a managed service, it retrieves you from various tasks compared to on-premise or building by yourself. In addition to Kafka itself, peripheral services like Kafka Connect and schema registries are also provided as managed services. Confluent Cloud is convenient, as you see, but furthermore, in-house tools are developed and used for automation of Merpay data platform. The CDC infrastructure sends data from different microservices to the same Kafka cluster, so access control for each microservice is required. In order to scale the administration tasks according to the number of microservices, it is better if the management of not only the Kafka cluster but also the topics and consumer groups in it can save effort as much as possible by eliminating human intervention. We develop and use tools for this purpose. During the development of this tool, the development of a Terraform provider for operating the Confluent platform from Terraform was started, and version 1.0 was released. We are considering whether we can switch to this tool for our current prototype. Next is about Kafka Connect and Debezium. Kafka Connect and Debezium are running on GKE Kubernetes. The Kafka Connect cluster is deployed using Kubernetes deployment. Clusters are separated for each database, and each connector is deployed as a Kubernetes job. In order to save human resources and labor, we use Customize to group common settings in one place and write only the small data to make it easy to build a new CDC. For monitoring, we use an orthodox way, sending JMX metrics to Datadog and monitoring on Datadog. We have also created and used a tool for connectors alive monitoring. Let me also briefly explain about security. Credentials to access Kafka and DB are stored and used in GCP's secret manager. From GKE, we use workload identity to associate GCP service account to Kubernetes service account, eliminating the need for GCP credentials to access secret manager. In addition, data retrieved from the database is encrypted before being sent to Kafka. Specifically, it is realized using the transformation function of Kafka Connect. This is available as OSS, so please refer to it. Let me summarize the first half of the report. In the first half, we described the Kafka-centric CDC infrastructure built on the Merpay data platform. We built a managed Kafka on Confluent Cloud and used Kafka Connect and Debezium to get data from DB and send it to Kafka. Kafka Connect and Debezium run on Kubernetes, and we develop and use our own tools to save labor and depersonalize operations. Here, I will now hand over to Mr. Nakamura for the second half. I'm Nakamura and a member of Merpay Data Platform team. I'm an engineer at Merpay using Python and Scala for nice data processing. The second half of the presentation, titled Stream Processing Infrastructure with Flink SQL on Kubernetes, will introduce how Merpay is building a stream processing infrastructure using AML's CDC data-based pipeline as an example. First, let's look at AML's data pipeline. Merpay still has a MySQL server running in an on-premise environment to which you can connect from a specific node pool on GKE. Using this node pool, GKE connects to the MySQL server with Debezium and sends CDC data to Kafka. Kafka uses Confluent Cloud, but we have built a dedicated cluster on GCP and VPC engineering with the GK cluster, so that we can send data without going out to the public internet. Data sent to Kafka is formatted and enriched using SQL in the Flink application on GKE and sent to PubSub. Enriched data is obtained from Cloud SQL. Data sent to PubSub is further sent to Splunk from the Flink application on GKE. Splunk uses HTTP event collector. Flink does not have a Splunk connector implementation, so we implement our own connector. Although the data is consolidated in PubSub once, it is configured in this way for the ease of throughput adjustment and because the data is delivered to BigQuery in addition to Splunk, making it easy to distribute the data to multiple destinations.
Flink does not have a BigQuery connector implementation, so we have implemented our own connector that we can write in real time. I will now describe how the Flink application is built on Kubernetes. There are several ways to run Flink on Kubernetes, but Merpay uses application mode for the standalone cluster. As a command to start the job manager, we use the entry point shell included in the official image. These commands are used to run the application in the form of starting the application on the job manager. Customize is used to manage the YAML for the job manager and task manager and to manage differences in the dev prod environment configuration. Deployment is done using Spinnaker, and Datadog is used for monitoring. Datadog uses HTTP Reporter to send metrics per application. Datadog logs are also used for logging. Next, let's look at Flink SQL. The diagram here is from the official Flink documentation and is very clearly presented. Flink SQL uses create table to convert stream data into what is called a dynamic table and then executes SQL against that dynamic table. In create table, the connection information and data format are described with. The result of the query is converted again into stream data by inserting it into the dynamic table. This is an example of actual processing of Kafka data with Flink SQL. Define the table from which data is retrieved from Kafka, the source table. That is the create statement on the left-hand side. The AML pipeline sends data to PubSub, so we define the destination table for the data, the sync table. That is the table on the right. The middle select insert statement processes the data by inserting from the source table into the sync table. Within the select statement, you can change the form of the data, call UDFs, and do joins to other tables. The AML pipeline uses PubSub as the sync table. Flink has a PubSub connector implementation, but it does not support SQL. As the issue was raised in Flink 23501, there's an implementation that can be used with SQL. We have a similar implementation on our own, which can also be used in SQL, just by specifying connector equals PubSub in the create statement. As with Kafka, you create a source or sync destination table and use it in the form of a select insert. The timing of the ACK return to the PubSub is the timing of the checkpoint, allowing you to deliver data completely on a checkpoint by checkpoint basis. Next, let's look at the data format. Avro is used as the data for Kafka. We use Confluent's managed schema registry as our schema registry. It is easy to use by simply specifying Avro Confluent in the key value format in the create statement. We use JSON for protobuf as the PubSub data. An issue was raised in Flink 18202, and we use this implementation. It will probably be officially supported from the next version 1.16 and can be easily used by specifying protobuf as format in the create statement and writing the class name. Next, let's look at join with DB data. In the case of CDC data, there are many cases where the data is normalized and is necessary to join to compensate for missing information. In Flink SQL, you can easily look up join stream data with DB data in a join clause. The table on the left for Kafka stream data. Add a field called proctime to the stream data. The table on the right is the DB data table, which references a PostgreSQL table via a JDBC connector. The join clause in the select statement specifies the join destination table, in this case the user table, and the full system time of is the proctime field added to the stream data. The actual query executed in the DB is thus a select statement specifying the ID in the where clause, and the data can be joined. There are several patterns to join methods other than the lookup join introduced here. There is a repository in GitHub called Flink SQL Cookbook Repository. So please refer to this. It introduces about 6 join patterns. Next, let's look at UDFs. UDFs are mainly used for date formatters and for implementing their own functions that can look up DB data in the same way as joins. Dates are often formatted differently depending on the source, and SQL tends to become complex if you try to deal with them using built-in functions, so we have defined functions that allow easy formatting. Functions that look up DB data are functions that simply throw a query to the DB and retrieve the results, and are used when you want to retrieve data that is tied to one-to-many as an array, perform aggregation processing that is easily complicated in SQL, or when there are many tables to join. This UDF allows tests to be written using H2 database, making it easy to test queries that are actually executed on the DB. Next, let's talk about HA mode. Flink can be configured for HA without using zookeepers on Kubernetes. It can be easily set up by adding about 3 settings to the Flink configuration file. Merpay uses GCS to manage data for recovery. HA configuration information is automatically managed in config map. About 4 such config maps, each named after a leader, are automatically created and managed. The HA configuration makes it possible to start several job managers with a single point of failure. If a job manager goes down, the standby job manager becomes the leader and automatically recovers jobs from the latest checkpoint. For Kubernetes, if it's an app where state is not critical and some downtime is acceptable, if the pod goes down, Kubernetes will automatically bring it back up again, so you can leave the management to Kubernetes. Next, let's talk about autoscaling. A feature called reactive mode has been added since Flink 1.13 and can easily be used by setting scheduler mode to reactive in the Flink configuration mode. Reactive mode is only supported in application mode for standalone clusters. In this mode, the number of jobs running in parallel is automatically matched to the number of task managers when the number of task managers is changed. This feature can be used for autoscaling in combination with HPA in the case of Kubernetes. Datadog metrics can be used as external metrics for HAP. External metrics can be used to scale out Kafka and PubSub based on the number of outstanding messages and latency. Kafka lag times can be estimated using the Kafka lag exporter, which is available on the OSS. Merpay has started using Datadog's external metrics to introduce autoscaling in applications where there is a difference in traffic during peak and off-peak hours. So finally, this is a summary. Merpay is using Flink on Kubernetes to build a stream processing infrastructure. We are able to easily perform formatting and data enrichment on streaming data using SQL. Since we are running on Kubernetes, we can share CI/CD monitoring and autoscaling mechanism with other applications, namely Go. Since HA configuration is easy on Kubernetes, we are building an environment where data can be delivered more securely in combination with checkpointing and safe pointing mechanisms. So that was all from me. Thank you very much.
Thank you very much for your watching. So, stream processing infrastructure with Kafka and Flink SQL on Kubernetes, and we'd like to answer questions. And MC for Q&A session will be by Tanaka and myself. At the data platform team, I am in charge of the pipeline development. So during this timing, I'd like to answer the questions from the audience. We are still accepting your questions, so please post it on YouTube Live or Twitter. The hashtag for the Twitter is MerpayTechFest. So when you post on Twitter, please use this hashtag. So we'd like to start Q&A session. First, thank you very much for your presentation, Tanaka-san, Mr. Tanaka. So let me ask you a question from me. So the first question. So the table scheme was changed in CDC. Did you have that type of case? So Debezium as well as Flink are related when there was a change. So, but Debezium had to do not have to be rebooted. So internally, the schema will be renewed. And on the side of the consumer, well, Debezium is not required, but GDC connector is if it is used on Kafka connector, the schema, database scheme is changed. That means query needs to be reconfigured or renewed. Okay, understand.
So the second question. So you have Kafka, but why do you use PubSub partially? In Merpay, there are many microservices. And to link with microservices, there are many teams who are more familiar with PubSub. So that is the first reason. And then, so when using Kafka from programs, so it is the best to use the official Kafka Java libraries, but many of the microservices are mainly made with Go. So we are not really familiar with the quality of the Go's Kafka library. So that's why we have not yet been able to fully implement Kafka in our company. And having said that, in the latter part of the presentation, we talked about AML pipeline. So the PubSub aggregated to send to Splunk. So we are actually sending data directly from Go applications.
Thank you very much. Let me move on to the next question. There are some cases that PubSub does not have order guarantee. And do you think there are the issues at real-time processing? Precisely speaking, the order guarantee is required. However, from the point of the contents of the data, as long as it is in BigQuery, that will be okay. So the order change, small order change does not incur any damage. So in this case, we just use PubSub because of that, because there are no vertical issues, big issues.
The next Question. So, what was the most impressive type of incident which happened during the operation? So, there has been an incident which occurred related to Debezium. From Debezium, so when extracting the RDB data from Debezium, the RDB schema's default value was non-null, and there was a nullable column. In RDB, there was a value called null, but we want this to be sent as null to Kafka, but this was changed to default value when sent to Kafka. And the countermeasures. So this data happened to be not very important or needed data. So we ignored that column. But I think there was a fix in the scheme history or something, but I'm not sure. Thank you. So it's very recent.
So anyway, you need to check it. You need to check data. It's better to check data, I think. Okay, thank you very much. Next question. How much do you handle? How much data do you handle? Well, per sec, around 3 to 5 megabyte. And in the case of the topics of Kafka, currently we handle 500 topics. So we design to use one topic per table. So on CDC, 500 topics will be captured as CDC in CDC. So let me ask you a question.
About this is related to the amount of data. So what is the latency of the pipeline? The AML pipeline is about a few seconds to a few dozens of seconds. So if it's 1 minute, their alert will come. So why are you using Flink, not Dataflow? So we were using streaming mode of Dataflow quite a lot in the past, but pipeline update or when ending, we could not do the drain processing. So there was times where we lost the data. So losing the data, we wanted to avoid. So we started using Flink as a different streaming platform, and the operation went well. So that's why we are continuing to use Flink. And in Dataflow, in streaming load, data can be easily lost. So that's why we replaced everything with Flink. And the cost has been lowered to about 1/3. The operation is not that difficult. Okay, thank you.
Any other questions? Any other questions from the audience? Well, should I wait for a while? A bit? It seems there are no questions anymore, so I think we should conclude this session. So there is a survey. So if you have any comments, please fill in the questionnaire. Thank you very much indeed for watching. Thank you. Goodbye.